Okay, graphing. So today, this weekend, the only graphing I want you to worry about are the displacement versus time ones. We'll get these down, and then on Monday we'll look at the velocity versus time. I've already posted the PowerPoint on the website or on our group that has all the notes for this. So you might want to go through and write the notes down and then come back and listen to me, but maybe listen to me, then go write the notes down, and then come back to the pieces that don't make sense. Okay, so the first question, and I think you did this in grade 10, is what is the slope of a displacement versus time graph? So if this is displacement on the y, and this is time down here, and you know slope is change in y over change in x, well, change in y is change in displacement, change in x is change in time. So this would be like d final, because change in is always final minus initial, over t final minus t initial. In other words, it's just delta d over delta t, and that's the average velocity. Okay, so slope of a graph is the average velocity. If we look at slope of a displacement versus time graph, if we look at the slope, then we can find its size by picking any 2 points. And if it's a straight line and I say find the slope at like 1.5 or find the speed of this object at 1 point, or velocity of this object at 1.5 seconds. You don't have to pick this point. You could pick any point along any 2 points along the line, right? So you could pick the 0, 0 and the 2.5 and 5. 2.5 seconds and 5 meters. Or you could pick the 1.5 seconds and 3 meters in the 0 and 0. Or you could pick the 1.5 seconds, 3 meters, and the 0.5 seconds and 1 meter. Doesn't matter which two you pick, you'll get the same slope, which means you'll get the same speed, right? So if I pick this one, which is 2.5 seconds and 5 meters, and I pick the 0, 0 one, so 0 seconds, 0 meters, and I do my slope, which is the VAV, so final displacement minus initial over final time minus initial, and I get 2 meters per second. It tells me then, the slope tells me the speed of the object and what direction. So the size of the slope, or the magnitude, will be how fast the object is going, and whether the slope is positive or negative will tell me is it going like east or west or north or south. So if this was an east-west graph, like your one, whoops, that's supposed to be west, your one is for homework, then this positive slope would tell me east. But I could have picked this point in here. I could have picked 1.5 seconds and 3 meters. I would still end up with the same value. The slope is constant. This would be 3, this would be 1.5. I'd still get 2 meters per second. Okay? So these 3 points that you're getting off the PowerPoint are just talking about all of that. And then it says find the velocity, and I think on yours it says 6 seconds, but it really should say, I think on the PowerPoint I say maybe 3 seconds, because there is no 6 seconds on this graph. All right. And then it goes through what are these graphs. So all of these graphs are displacement versus time. So the first question is, what's the slope? Well, hopefully you recognize this graph as a positive slope, and it's constant. So that means this object is traveling in the positive direction and at constant speed. It actually, if you look at it, it starts down here below the origin. So it's starting on the negative side of the origin and traveling through the origin past it. It might kind of be like you're down the street from your home, so your home would be the origin, and you're to the west of your home, and you leave your home and traveling in a constant, or you leave the friend's house you're at, and you walk up the street traveling at a constant speed towards your house, but when you get there you keep going and you go to the corner store and you buy ice cream before you go home because you're worried there's no snacks. Okay, so this object's traveling in a positive direction at constant speed because the slope isn't changing, and because the slope isn't changing, it means there is no acceleration. A is equal to 0 meters per second squared. Graph 1. Graph 2, slope is still constant, but this time it's negative. So this object then is traveling still at a constant speed or a constant velocity, but in a negative direction. There's still no acceleration, so it's a constant velocity, but in a negative direction. Next one's easy, I think. I hope. Okay, if this is displacement and this is time, what's happening to the object's displacement over time? Absolutely nothing. The object is staying still. There is the velocity, the slope is 0, which means the velocity is 0, and if the velocity isn't changing, the acceleration is 0. So this object is staying still. D. This time the slope is not constant. So the velocity is not constant, which means there is an acceleration. And it's positive because the slope is positive. But if you look down here, you'll see the slope isn't very big. It's almost horizontal. But as time goes on, the slope's getting bigger. So it means the slope is positive, so it's traveling in a constant direction. But it's also speeding up. And we know it's speeding up because of the way the slope is changing. The slope is getting bigger, which means the velocity is getting bigger. So we would say the object is traveling in a positive direction and it's speeding up. So the acceleration would be positive. Okay? Next, turn the page. Oops, I don't have anything on the back of my page. Let's try this one. There it is. E. Okay, again, slope is not constant, which means velocity is not constant. But this time the slope is decreasing. It's big here, and it's getting closer to horizontal here. So the slope is decreasing, which means the velocity is decreasing. So this object is slowing down. Okay, so, but it's above the, so it's slowing down. So it's still moving in a positive direction, because this, I said the slope was, it's moving in a positive direction, but it's slowing down because the slope is decreasing. I think I might have said that, I'm not sure what I said there, if I said that the slope was negative or not. Anyway, so it's slowing down because here the slope is steep, here it's leveling out, but this is a positive slope, not a negative, no matter what I said earlier. Sorry about that. All right, next one. Now the slope is negative. Okay, so this object is traveling in the negative direction. Here it's steep. Here it's lower. So this object, this object is slowing down, but in the negative direction. So slowing down equals a negative. And traveling in the negative direction equals a negative. And so if you have two negatives, you're going to end up with a positive slope here. But it's positive because it's slowing down in a negative direction. Okay, so the acceleration we would actually say is positive. Because if you're traveling west and you're slowing down, it means whatever's slowing you down, the force, your brakes, they must be acting east. Okay, so if you're slowing down in the negative direction, the acceleration will end up being positive because two negatives make a positive. Okay, next one. This time the slope is getting what? I hope you answered bigger. Okay, so it's low here and it's getting straighter here. So the slope is increasing, but it's still negative. So this means the object is speeding up in the negative direction. The velocity is getting bigger, but it's still negative. So speeding up in the negative direction. This one, it's changing. Here, it's big. Down here, it's almost horizontal. And then here, it's